Kun je met gekweekte mini-organen in het laboratorium voorspellen wie baat heeft van een behandeling en wie niet? Sinds 2014 is het antwoord op deze vraag ja. Mijn team heeft samen met veel collega's laten zien dat de effecten van medicijnen voor taaislijmziekte voorspeld kunnen worden in gekweekte mini-darmpjes van patiënten met taaislijmziekte. Hierdoor hebben we mensen die zeldzame vormen hebben van taaislijmziekte, die eigenlijk geen toegang hebben tot medicatie, kunnen selecteren voor levensreddende behandelingen. Ik denk dat de consequenties van dit werk veel breder zijn nog dan alleen taaislijmziekte. Ik verwacht dat voor een aantal andere ziekten mini-orgaankweekjes gebruikt zullen gaan worden om optimale individuele behandelingen te gaan selecteren. Maar daarnaast ook in geneesmiddelenonderzoek. We kunnen straks veel sneller de juiste kandidaatmedicijnen selecteren door gebruik te maken van gekweekte mini-orgaantjes, waardoor we ook het proefdiergebruik kunnen verminderen. Ik ben dan ook zeer trots, en mijn team met mij, dat we genomineerd zijn voor deze fantastische prijs en we kijken uit naar de uitreiking.
Nearly half the adult population suffers from at least one chronic disorder. However, we know that individual drug responses can vary greatly, and treating patients who do not have a desired response has been a major clinical and economic burden. My research aims to determine whether we can improve drug efficacy by manipulating the gut microbes. The first line of my research is to reveal genetic and gut microbiome factors that we can use to improve drug efficacy by conducting a large-scale analysis in the population-based lifelines cohort. Then the second line of my research is to test these targets in a personalized drug testing model that takes individual genetics and gut microbiome into account. This combines organs on chips with other state-of-the-art technologies, including human-induced pluripotent stem cells and gut microculturomics. I really believe that combining the human genome with our second genome, the gut microbiome, will pave the way towards personalized medicine.
What I really like is to work in the interface of biomaterials and chemistry. So my first start is always chemistry. I start making and designing polymers, molecules that are functional and they can be used for biomedical application. In my group there are two teams that are really important, and one team is working on biomaterials for 3D printing. The other team is working on drug delivery. The research is indeed quite diverse, but the basics are the same, and that's where I come from. I'm the chemist, so I design the materials and I'm looking for different places where I could apply them. So the building blocks for those two different applications are basically not that different. We really work with the same types of polymers, but in one time we make nanoparticles out of them, and the other time we make a big hydrogel out of them. In my group, we have people with different backgrounds. So we have chemists, pharmacists, physicists, and they really collaborate a lot on different topics. In terms of what we've achieved so far, we've had a lot of interesting publications, but most importantly, I think I can really bridge the gap between, in communication between a clinician and a fundamental scientist, like chemists, the physicists, each have their own speciality. But I'm now broad enough to really communicate between both and translate fundamental science to biomedical application.